Everyone, this video is on exercise 14C question 3, and this is about exponential modeling. So we have the number of people who are infected with the disease, and that's modeled by this formula, where n is the number of people infected and t is the time in years after detection. So it's very typical that they first give you a formula, and then in the first part they ask a very basic question. So in this case, the first question is how many people were first diagnosed with this disease? Right, so whenever they say how many people or how many things were affected at first, that's talking about when t is equal to 0. So all you need to do in this case is to substitute t is equal to 0, and then that gives you the initial number of people. So we have n is equal to 300 minus 100 e to the power of minus a half times 0, which is just 0. So e to the power of 0 is 1. We'll have 300 minus 100, and that's 200. So this means that the initial population is just 200. In part B, the question is, what's the long-term prediction of how this disease will spread? Right, so in terms of the long-term prediction questions or long-term behavior, we just need to assess the limiting behavior of the formula. So in this case, the formula is again 300 minus 100 e to the minus half t, and we need to analyze the behavior and see that as t increases and tends towards infinity, then what will happen to this function as a whole. So since we have an exponential function, but the power is negative, remember that as the power gets very large, then since we have negative a half, then they are basically in total is going to be negative infinity. And when we have e to the power of negative infinity, then that just tends to 0, because that gets extremely small. And if this term approaches 0, then also 100 times 0 is going to be 0. So therefore, we can say that as t approaches infinity, then e to the minus half t approaches 0. So as a result of that, n tends to 300 minus 100 times 0, which is 300. So this is basically saying that over a very long-term period, the population is going to be equal to 300. And finally, in part C, we want to sketch the graph of n against t, and that's for positive values of t, because time can't be negative. Right, so in terms of the graph, we just need to check a few things. So again, I start by writing down the formula, because we're going to need that. So e to the minus half t. Right, so the first thing is that as we found in part A, when t is equal to 0, n is equal to 200, and that means the y-intercept is 200 basically. So let's say here is 200. That's the first thing. And also the second thing is that we'll have an asymptote at the line y is equal to 300. That's just because as we worked out in part B, basically the value of n approaches 300, but it will never be equal to 300. That's why 300 is going to be an asymptote here. And obviously we don't need the negative part, so just ignore that. And since this exponential starts from 200 and also it's decreasing, then the graph is going to look like this. So maybe slightly yeah, I think this one's better. Yeah, because this is negative, that's why the exponential here looks like this. And yeah, so that's basically the graph.